Hello there and welcome to Lower 6th Further Maths Pure Core 1, June 2012. We're working on question 1 here. This question is new to Pure Core 1, so it's been added in to the FP1 from June 2012. So, a transformation T is represented by the matrix A. Show that A is non-singular for all values of A. Now, non-singular means a singular. If a matrix is singular, the determinant of the matrix is equal to 0. So what we have to do here is prove that for all values of k, this matrix can never equal, the determinant of it can never equal 0. So the determinant of A is k times k, which is k squared, take away 2 times that, so it'll be plus 2 of 1 minus k. So this is going to be k squared, take away 2k, add 2. And the way that I can prove that this is never going to equal 0 is I'm going to prove that this is always going to be positive by completing the square. K minus 1 squared, I'll need to take away 1, but I've got an add 2 here, so it'll be plus 1. So from here, I can show that that's always going to be greater than 0, as it's 1 plus something squared, which is going to be greater than 0. So that's part A complete. Part B is find A minus 1 in terms of k. So I've already got the determinant for A, which is going to be k minus 1 squared plus 1. And in the brackets it's going to be, so we flip round the leading diagonal, k and k, and then we negate the other two values, so it's going to be 2 and k minus 1. That's not too bad for 3 marks. Part C is going to be find the value of k such that the line y equals 3x is mapped onto itself. So what it means to have a line mapped onto itself is that if we take any coordinate on that line, say the coordinate 1, 3, once we apply our transformation, it's going to end up at another coordinate along that line. Maybe the same coordinate again, but it's going to be along that line. So what we can say is that once we've applied the matrix k minus 2, 1 minus k, k to the line x, 3x, where we're using the y coordinate as the value 3x, this is going to be transformed to somewhere else on this line. It could be greater along the line, could be smaller along the line, could be negative along the line. So it's going to be some multiple of a vector still along that line. So what I need to do is I need to expand the top, expand the bottom, and then solve some equations. So expanding the top, I'm going to get kx minus 6x equals lambda x, or in other words, k minus 6 equals lambda. And for the next one, it's going to be 1 minus k lots of x, add 3kx equals 3 lambda x, or in this case here, it's going to be x minus kx plus 3kx equals 3 lambda x, and cancelling out the x's and combining these two terms here, 1 plus 2k equals 3 lambda. So solving these equations, I know what my value of lambda is, so I'm going to substitute this value of lambda, k minus 6, into this equation here. So it's going to be 1 plus 2k equals 3 lots of k minus 6. Expanding the brackets and taking over to one side, I'll get 3k here, so take away the k, 2k over to there, so I'll get k here, and I've got 1 here, I've got 18 here, so add 18 onto the side and I get 19. So 19 here is my value for k. 3 marks for that, 9 marks in total.